This is now the outcome or the result of the capacitor with a lower working voltage. As what I have said a while ago, that the working voltage of this capacitor or the dielectric strength of this capacitor is only 16. But the applied voltage of this power supply to this capacitor is somewhere at 30 volts. So, the dielectric strength of this capacitor cannot withstand the applied voltage. It results to breaking down. So, it is very important for us to take into account the working voltage of every capacitor. It is very important, the working voltage, before you install or connect it to the circuit, no? Okay, let us now come again here. Remember that these are the tolerances marked on the surface of the capacitor. They are also printed, no? Not only the capacitance, but also the tolerances as well as the working voltage. Then also, okay, for the surface mount device, because the most commonly used capacitor nowadays in the latest technology are those surface mount device. The capacitors which are actually mounted on the surface of this, for example, the computer board, no, the motherboard of the computer. There are lots of SMD here, the surface mount devices, the resistor, the capacitor, the inductors, or we call the so-called chip resistor, chip capacitor, or chip inductor, which are mounted on the surface of this solder side. No, we have lots here. Okay, some of them are actually these capacitors. SMD electrolytic capacitor, wherein 22 actually is the capacitance value in picofarad, and 7 is the multiplier or the number of zeros. There are 7 zeros. Okay, we have here 2 to 7 now indicates the number of zeros, which is 0, 0, 0, 0, 0, 0, 0. Then it is picofarad. 1, 2, 3, 4, 5, 6, 7. There are 7 zeros. So, that is 220 million picofarad. So, when converting it to micro is bigger or larger unit because -6 and pico is -12. You are now converting a smaller unit, pico, into a larger unit, micro. The difference between them is 6. So, when converting a smaller into larger unit, you have to move decimal point over here 6 places to the left. 1, 2, 3, 4, 5, 6. That becomes 220 microfarad. And the working voltage now is A. What is this A? So, it is 10 volts B. Let us see kung meron tayo. If we have here the working voltage. Okay. Oh, that was the tolerance. So, we have heard the working voltage. A while ago, that was 227A. The A now is actually the working voltage we have here. A is 10 volts. If the letter marked there is G, that is 4 volts. Small e is 2.5 volts. H is 50 volts. No? It goes like that. Okay. Let us go back to the here. Breakdown voltage is only 10 volts. If you are applying voltage to the capacitor, which is 15 volts, surely this capacitor cannot withstand the applied voltage, so it will break down. No? Break down. We call it SMD, surface mount device, which is located at the solder side of the PCB, or printed circuit board. So another here, we have here. Then another example, 474M. We have here 474M. 474M. What is that 474M? Again. (474M). We have here 474M. with a working voltage of 125 volts. So working voltage is always indicated. No? If not indicated in numerical value, it is always indicated in liter. There is a corresponding value for the liters. Diba? Okay. 474. 4 here is the number of zeros. Usually there are 4 zeros. It is times 10 kilo ohms or times 10 picofarad. No? 47 times 10,000 picofarad. Or just write it automatically. 4 zeros. Because it is 4. So that becomes 470,000. 470,000 picofarad. More or less 20%. And the working voltage now is 125 volts. But it is necessary for us to convert this into a unit which can give least number of digits. So let us try micro. Pico to micro again. You are converting smaller into larger. So pico is negative 12. Micro is negative 6. The difference between them, or the gap between them, is 6. So decimal point is over here. We are converting smaller into larger, so we need to move decimal point to the left. How many places? It's 3. I mean 6. So it is 6. No? 1, 2, 3, 4, 5. So that becomes 4. How many zeros do we have here? I see. 1, 2, 3, 4, 5, 6. That becomes 0.047 microfarad. That is now the equivalent value in microfarad for the 474, which is in pico. Diba? We cannot read this one as 474 picofarad because there is still a multiplier. So, converting this or translating this into zeros, we have here 4 or 4 zeros. That becomes 470,000 picofarad. Or in micro, that becomes 0.47 microfarad. Or in nano, pico to nano. Pico is negative 12. Nano is negative 9. So the gap between them is 3. Again, we are converting smaller to larger. So we need to move decimal point 3 places because the gap between them is 3 only, diba? So 1, 2, 3, that becomes 470 nanofarad with a working voltage of 125 volts and a tolerance of 20%. There is a wider tolerance compared to 10%, diba? Okay. Now let us now come. Can we replace this type of capacitor to another type of capacitor? Instead of using polypropylene, we will use polyester. Or instead of polyester, we will use polystyrene. That can be. No, it can be. We can replace as long as the capacitance and the working voltage are the same. Or the given working voltage is applicable to a circuit. No? Okay. It doesn't mean to say that once it is 1 kilovolt, it can also store 1 kilovolt. No. If the applied voltage is only 10 volts, then the working voltage of that capacitor is 25 volts. Only 10 volts can be stored, just like a while ago. Diba? This is 50 volts, but the amount of voltage which is stored here is only 9.5 volts. So, no? We can use, instead of using 50 volts, we can replace it with 16 volts. Working voltage with the same capacitance, 2,200 microfarad. No? As long as the applied voltage cannot exceed the working voltage. Okay. These electric capacitors actually are very applicable as a ripple filter. Ripple filter in this power supply. No? We have here. Okay. We have here actually. This is now the AC voltage outputted from this transformer. No? Step down transformer wherein the 220 volts is lowered down to the secondary to how much? 25, I think. 25. No? Set it to AC volts. We have here AC. Then measure. It is 25.7 volts. In a power supply, AC to DC power supply, because electronic circuits, electronic devices such as TV receiver, amplifier, radio receiver, cellular phones, computers, the electronic circuit there need DC voltages. So power supply is the answer for that. At first, it is lowered down to lower amount of voltage, 25 from 220, before it is rectified by this diode. And we have here actually the AC volt, the AC volts. Then after rectification by this diode, it goes like this. We have here, no? We are actually using two channels of this oscilloscope. Channel 1, displaying the AC waveform outputted by this transformer. And this channel 2, displaying the resulting pulsating DC. We have here, the AC is converted to DC at the output of this diode. Now, what is the purpose of this capacitor? The capacitor now, look at this one. This is now the DC, which can be applied already to the amplifier circuit, for example. But it is still pulsating. There is 60 hertz. 60 hertz actually is audible to the human ears, because audio frequency or the sound frequency or the sound frequencies or the audio frequencies which are audible to the human ears are ranging from 20 hertz to 20,000 hertz. No? So 60 hertz is still within that audio frequency, and so we can hear that one. And when it is applied to the circuit, there is music, but it is accompanied with hum or oscillating sound that can give an undesirable sound. It is a noise. No? There is a variation of, halimbawa, it is 25-0, 25-0 pulses. To minimize that hum, let us filter out or smooth out the pulsation using capacitor. Okay, we have here. When the capacitor is applied, okay, it goes like this. Okay. It is almost, we have here pala. Okay. When this capacitor is applied, it is almost DC, no? It is purified, in other words. Okay, we have here this capacitance. It goes like that. This is ripple, no? Ripple or pulsating DC, which can cause hum or disturbing sound. But when it is filtered out by a capacitor, it is smoothed out. The pulsating DC or the ripple is being smoothed out. But if you are using a larger capacitance, just like this, it can purify almost. It can purify into purified DC or almost no more variation, no? No more variation. Meaning to say, when you use higher capacitance as a filter, then it can purify not only varying DC, like this one, it is varying DC. You can still hear sound, a little amount of hum, because there is still variation of voltage, a little amount of voltage that can be heard, no? But when you are using higher capacitance, of course, almost no more pulsation, no more variation of voltage. That's the essence of capacitor as a filter. But remember that there are many uses of these capacitors. Not only as a filter capacitor to smooth out the pulsation, but it is also a bypass capacitor to remove the noises at the amplifier circuit. It can also serve as a neutralizer. It can also serve as a coupling coupling the AC signal, especially from the microphone. For example, from the radio frequency transmitted by the radio transmitters, they are being coupled because capacitors are capable of coupling or passing the AC signal. Okay? Okay, that's all, my dear students. If there are still confusion in your mind regarding capacitor, do not hesitate to ask me. Just send your questions and suggestions to me, no? All of those queries will be responded. I will assure you. Thank you very much, and so long for the lesson 3, which will be all about inductors. Okay, bye-bye.